Hello friends, my name is R.Mogal from KTHM College, Nasik, Department of Computer Science. Today we will discuss our second unit, that is Fundamentals of Fuzzy System. In this lecture, we will study some introduction part of fuzzy system, then what is fuzzy logic, then basic architecture of fuzzy logic system, then classical and fuzzy sets, then operations on classical sets and properties of classical sets. Now we will see some introduction of fuzzy system. All of you know that fuzzy system developed in 1965 and the inventor is Professor Dr. Lotfai-Zade. Fuzzy system was developed in 1965 by Professor Lotfai-Zade at University of California. The first application was to perform computer data processing based on natural values. Lotfai-Zade is the father of fuzzy logic. It defines as a many valued logic form which may have truth values of variables in any real number between 0 and 1. Fuzzy means not clear or vague or rough value. It is the handle concept of partial truth. In real life, we may come across a situation where we can't decide whether the statement is true or false. At that time, fuzzy logic offers very valuable flexibility for reasoning. Fuzzy logic algorithm helps to solve a problem after considering all variables of all available data. Then it takes the best possible decision for the given input. The fuzzy logic method imitates the way of decision making in human which consider all the possibilities between digital values true and false. Fuzzy logic is an extension of Boolean logic by Lotfai-Zade in 1965 based on the mathematical theory of fuzzy sets, which is generalization of the classical set theory. We will see what is fuzzy logic. Fuzzy means not clear or distinct or vague. Fuzzy logic resembles the human decision making methodology. It deals with vague and imprecise information. Fuzzy logic is a mathematical logic which attempts to solve problems with an open, imprecise spectrum of data that makes it possible to get an array of precise findings. Fuzzy logic is designed to be considered the best possible decision by considering all available information and looking an input. Fuzzy logic is a method of reasoning that resembles human reasoning. The approach of fuzzy logic imitates the way of decision making in humans that involves all intermediate possibilities between digital values yes and no. In this example, we can say that in Boolean, we may say it is cold, then its value in Boolean logic values are only true or false, yes or no, and 1 or 0. Okay. In fuzzy logic, we may say that it is very much cold, it is little cold, or it is very less cold. This is the fuzzy logic. Means Boolean logic values are yes or no only, 0 or and 1, and in fuzzy logic there is a value certainly yes, possibly no, can't say, possibly yes, etc. Now we will see the basic architecture of fuzzy logic system. A fuzzy logic system consists of the following modules. First module is fuzzifier. It accepts the major variables as input and converts the numerical values to linguistic variables. It transforms the physical values as well as the error signals to a normalized fuzzy subset, which consists of an interval for the input values range and membership functions that describe the probability of state of the input variables. The input signal is basically split into 5 states as in large positive, medium positive, small, medium negative and large negative. Second module is controller. In that, it consists of the knowledge base as well as the inference engine. The knowledge base stores the membership function and the fuzzy rules obtained by knowledge of system operations per the environment. The inference engine performs processing of the obtained membership functions and fuzzy rules. In other words, the inference engine assigns outputs based on linguistic information. Then last module is defuzzifier. It performs the reverse process of the fuzzifier. In other words, it converts the fuzzy values to the normal numerical or physical signals and sends them to the physical system to the control system operation. Now we see classical and fuzzy sets. First we see the basic definition of set. A set is an unordered collection of different elements. It can be written explicitly by listing its elements using the set bracket. If the order of the elements is changed or any element of a set is repeated, it does not make any changes in the set. Example, a set of all positive integers, a set of all the planets in the solar system, a set of all the states in India, a set of all the lowercase letters of the alphabet. Then, mathematical representation of a set. Set can be represented into two ways. First one is roster or tabular form. In this form, a set is represented by listing all the elements comprising it. The elements are enclosed within braces and separated by commas. For example, of set in roster or tabular form, the set of vowels in English alphabet A is equal to A, E, I, O, U. Then set builder notation. In this form, the set is defined by specifying a property that elements of the set have in common. The set is described as A is equal to curly braces X colon P of X. For example of set builder notation, the set A, E, I, O, U is written as A is equal to curly braces X colon X is a vowel in English alphabet, curly braces closed. Then definition of classical set. Classical set is a collection of distinct objects. For example, a set of students passing grades. In an individual entity in a set is called a member or an element. Then we will see that operations on classical sets. Classical set, in classical set, let A is a given set. The membership function can be used to define a set A is given by membership function of A of X in curly braces 1 if X belongs to A and 0 if X does not belongs to A. Then operations on classical sets. Set operations include set union, set intersection, set difference, complement of set and Cartesian product. In union, first operation on classical set is union. The union of sets A and B. If there are two sets A and B and universe X, then A union B is equal to curly braces X belongs to A or X belongs to B. This operation is also called as logical OR. Then intersection. Second operation of the classical set is intersection. The intersection of sets A and B denoted by A intersection B is the set of elements which are in both A and B. Hence, A intersection B is equal to curly braces X tends to X belongs to A and X belongs to B. This operation is also called logical AND. Then complement. The set difference complement, the complement of a set A denoted by A complement is the set of elements which are not in set A. Hence, A complement is equal to X tends to X does not belongs to A. Then difference. The set difference of sets A and B denoted by A minus B is the set of elements which are only A but not in B. Hence, A minus B is equal to X. X belongs to A and X does not belongs to B. Now we will see properties of classical sets. Properties on sets play an important role for obtaining the solution. Following are the different properties of classical sets. First property is commutative property. Having two sets, if there is having two sets A and B, then this property states that A union B is equal to B union A and A intersection B is equal to B intersection A. Then second property is associative property. If there is having three sets A, B and C, then this property states that A union B union C then is equal to A union B, B union C. If A intersection and B intersection C, then A intersection B with intersection C. Then third property is distributive property. If there is having three sets A, B and C, then this property states that if A intersection A union with B intersection C, then A union B and A union C with intersection A union B intersection A union C. If A intersection with B union C, then A intersection B union A intersection C. Then fourth property is idempotency property. For any set A, this property states that A union A is equal to A and A intersection A is equal to A. Then last property is identity property. Identity property. In identity property, for set A and universal set X, this property states that A union phi is equal to A intersection X is equal to A intersection phi is equal to 5 and phi and A union X is equal to X. Then we will see transitive property. If there is having three sets A, B and C, this property states that if A subset of B and B subset of C, then A subset of C. Last property is involution property. For any set, this property states that A involution is equal to A. Now we see two special properties of classical sets are known as the excluded middle axioms and De Morgan's principles. The excluded middle axioms not valid for both classical sets and fuzzy sets. There are two excluded middle axioms. The first, called the axiom of excluded middle, deals with the union of set A and its complement. Then A union not A is equal to X. The second, called the axiom of contradiction, represents the intersections of set A and its complement. That means A intersection not A is equal to phi. Then De Morgan's principle states that not A union B is equal to not A union not B, and not A intersection B is equal to not A intersection not B. Today's lecture we will stop here, and in next lecture we will see that the basic definition and terminology of fuzzy sets operations, Cartesian product of fuzzy set, then fuzzy logic and its relation, and membership function, and problems on fuzzy sets. Okay, thank you.